Experiencing the beauty and complexity of the cosmos, learning to read the night sky, and unlocking the secrets of the universe. This is what draws so many people to astronomy. Even for beginners, to gaze through the eyepiece of a telescope opens up a breathtaking world filled with stars, galaxies, and nebulae millions of light years away. At the same time, astronomy is a lesson in patience and perseverance. Stargazing gives us a sense of the infinity of the universe and reminds us of the wonder of our own existence.
It's an age-old question for humankind. What is our role in the universe? As the philosopher Bertrand Russell once said, "The great world so far as we know it, from philosophy of nature, is neither good nor bad, and is not concerned to make us happy or unhappy. All such philosophies spring from self-importance and are best corrected by a little astronomy." So, observing the sky brings us down to Earth, and the best places to get to know the universe are planetariums and observatories. But even a little equipment of your own, like these binoculars, will reveal a lot about the universe.
The night sky has always fascinated humankind. For many, observing the universe is a deeply enriching experience. Time and again, gazing deep into space can stir philosophical reflections. It leads to the big questions. Where do we come from as part of this vast cosmos? Where are we headed? And are we alone in this infinite universe?
Ich glaube, es ist dieser Gedanke, der zählt.
I think this is what really matters, that we have a window into what is essentially near infinity. There must be so many fascinating things out there that we can't even begin to imagine. And that idea has a powerful pull, especially for people who are as curious as I am.
For many of us, looking up at the stars has become almost incidental, something we rarely take the time to do. What's more, in urban areas, artificial light drowns out the night sky. Stars and even the Milky Way are barely visible. This phenomenon is known as light pollution or light smog. Amateur astronomer Joost Jan lives on the island of Amrum in the North Sea. It's far from the bright lights of a big city, but still not an ideal location for astronomers.
On islands, you're inevitably going to have high humidity due to the surrounding sea. This means that you have many clear nights, but also many nights where a dew forms, leaving a haze in the atmosphere that keeps you from observing the sky.
Astronomy isn't just a casual pastime. It requires knowledge, experience, and the right equipment. But to begin observing the sky, you don't need complicated optical devices. All it takes is a glance upward on a clear, dark night to feel closer to the universe. Still, to understand what they're seeing, an amateur astronomer first has to get their bearings. They need to become familiar with the night sky.
So you can use the constellations to get an orientation in the night sky. Then you can say, for instance, that the brightest star in the constellation is this and that, and on a star chart you can see that there's the next star and then there's the object I want to zero in on.
Awareness of the night sky once played a greater role in everyday human life. For centuries, navigation relied on familiar constellations and celestial bodies, visible markers in the skies of both the northern and southern hemispheres. Today, it's mostly scientists and researchers who observe the night sky. But even now, a conscious look upward can still offer a sense of orientation if you know what you're looking at.
I look up, I see the Big Dipper, I see the North Star and think, that must be north. And suddenly I have this sense of direction. That was second nature to me when I was little. I was a Boy Scout, and that was just something we learned. Even as an astronaut, before you climb into a rocket, you should know your way around out there. When you catch a glimpse of the stars from the spaceship and you're trying to orient yourself, it really helps to know the sky.
The easiest way to navigate the night sky is with a star chart, either the classic rotatable disk or a digital version on a computer or smartphone. For aspiring amateur astronomers, getting familiar with the night sky is essential. Whether you look up with the naked eye, binoculars, or a telescope, you won't get far without orientation. You don't need to recognize every constellation, but knowing a few key reference points, like the Northern Star or the Big Dipper, makes all the difference.
The era of celestial observation began around 3000 BC in both Egypt and Babylonia, modern-day Iraq. The Egyptians were only interested in predicting the next time the Nile would flood. Babylonian priests, on the other hand, believed that the stars were all gods, and they believed in astrology. The first record of astronomy in Central Europe comes around 2000 BC with the famous nebulae sky disk. Then the Greeks turned all this knowledge into a science. They were able to demonstrate the orbits of the planets mathematically, and this knowledge lasted until Galileo in the Middle Ages, who delivered a precise demonstration of these movements with his telescope. And that marked the beginning of the Enlightenment, because people understood that you can fathom the world better with instruments like these.
The nebulae sky disk is the oldest known representation of the northern night sky. One of its most fascinating features is the depiction of the Pleiades, an open star cluster that remains clearly visible in autumn and winter. A major leap forward came in 1609, when Galileo Galilei used a telescope to observe the heavens for the first time, marking the beginning of modern astronomy. Just a few years earlier, the renowned astronomer Tycho Brahe still had to make do without a telescope. Then, as now, the foundation for all scientific observation is mathematics.
Galileo didn't change astronomy entirely. He added another aspect by enlarging it. You could actually see more. You could clearly see the craters on the moon. You could see that there are more stars in the sky than are visible to the naked eye. But this still wasn't the astronomy we have today. It was just more of a descriptive story of what you could see in the starry sky. But of course, it's a significant milestone when you can see it enlarged.
Galileo did not invent the telescope. That credit goes to lens makers in the Netherlands. But he was probably the first to turn this new instrument toward the night sky. Through his telescope, he observed the moons of Jupiter, marking the first time anyone had seen celestial bodies orbiting something other than the Earth. It was a powerful argument against the long-held belief that everything revolved around our planet. He also observed the phases of Venus, proof that Venus orbits the Sun. And if Venus does, then so must the other planets.
It is perhaps interesting to mention that what Galileo had as a telescope, even the worst department store telescope today is better than what Galileo had. And yet he was still able to see the moons of Jupiter, that there were these little dots revolving around Jupiter. And that was one of the key things he discovered, because he was able to show that not everything revolves around the Sun, and instead there are obviously lots of little dots revolving around another planet.
Observing the night skies has shaped our understanding of time, from the prehistoric era down to the present day. The apparent movement of the sun and stars, the cycle of day and night, and the changing seasons have long guided daily life. Throughout history, religion and agriculture have been influenced by knowledge of the calendar and celestial events, and ultimately by an ever-growing understanding of cosmic mechanics.
Actually, it really wasn't understood until Newton discovered how gravity works. Up until then, people tried to find some kind of system to explain the movement of the stars. The simplest movement was circular motion. Since the heavens belonged to God, the assumption up until then was that everything was round and circular. It was a kind of dogma. But people realized that the planetary system didn't work very well, because back then everything was supposed to revolve around the Earth. So they just added more circles known as epicycles. That on this circular orbit, the planet would once again orbit around a circle. So they introduced another circle. At some point it became so complicated that you could calculate all these things in advance to some extent, but they never really understood what was going on.
In ancient Mesopotamia, between the Euphrates and Tigris rivers, priests and scholars were charting the stars more than 3,000 years ago. The towering ziggurats, called Mountains of the Gods, were places for observation and worship at the same time. From these sacred structures, kings and priests symbolically ascended into the heavens to interpret the stars and predict earthly events. Priestly astronomers held significant power, both in politics and religion. The Babylonians meticulously recorded their observations on clay tablets written in cuneiform. They understood that all planets move on a single plane, the ecliptic. Around this celestial line lies a band of 12 constellations, the zodiac, which would become central to astrology. At the time, astronomy and astrology were still one and the same.
People just thought it was something that came from above, from the gods, and that somehow had to have an influence on people. What was happening up there? At the time, no one dreamt that it had no influence at all.
It was in ancient Greece that the foundations were laid for the separation of astrology and astronomy. Faith-based interpretations began to give way to rational thinking. From myth to logos, understanding the world through reason alone, that was the approach of the Greek natural philosophers. The principles they established in physics and celestial science laid the groundwork for modern-day astronomy. Centuries later, Galileo Galilei opened the door to the universe. Telescopes became more powerful and more widespread across the globe. By the end of the 19th century, refracting telescopes reached their golden age. An impressive example was the Great Refractor, completed in 1899 on Telegrafenberg, a hill near Potsdam, Germany. This giant instrument became a symbol of Prussian progressiveness. Even the emperor himself attended its dedication. At the time, it was the largest telescope in the world.
Of course, it's more fun when you gaze into space yourself. The moon and our planets are the most beautiful to behold, especially Jupiter with its many moons. Planetary nebulae and galaxies are also stunning for their colors. What equipment do you need? Well, simple binoculars are enough for the moon. For the more distant objects, you'll need a hobby telescope like this one, for example. Along with the optics, a good mount and a sturdy tripod are very important because nothing should wobble.
It all begins with the question, what do you want to observe? In amateur astronomy, we can roughly distinguish between two areas of focus. First, there's observing the moon and the planets in our solar system. And then there's the observation of deep sky objects beyond our solar system. Stars, especially variable stars, star clusters, galaxies, and nebulae. Even observing with the naked eye holds a special kind of fascination if you know what you're looking at and where it actually is in space. And it doesn't even have to be nighttime. Our planetary neighbor Venus often appears in the sky before sunrise and after sunset.
So you can follow the course of the stars with the naked eye. You can see the moon, the phases of the moon. You can see the migration of the planets. Occasionally you can see comets. You can even observe variable stars. Some stars vary in brightness, and the brightest ones are visible to the naked eye. This is how the brightest star, the first variable star Algol in Perseus, was discovered with the naked eye. But it's just not that much to see in the long run, I'd say.
If you want a more detailed view or a deeper look into the night sky, you'll need optical assistance. There are two main types of instruments used for more precise observation. First, the classic telescope, the refracting telescope, or simply refractor, the modern descendant of the optical device that Galileo Galilei used to make his discoveries. Small refractors are typically lightweight, portable, and affordable. They offer sharp images and high contrast. But if you're aiming to observe fainter objects, you need a large aperture to collect enough light. That's where refractors become impractical, heavy, bulky, and expensive.
If you're a beginner, I'd recommend getting a pair of binoculars if you want to get to know the night sky. The best binoculars available, of course, but they don't have to be super expensive. And first, try to see if you like what you see through them, because you'll already be able to see much, much more than with the naked eye. An app isn't a bad way to get to know what you're looking at either. For beginners, it's important to look for acquaintances, friends, observatories, public observatories, or planetariums where you can learn something from the community, because your friends there are very sociable, even if you might not think so.
For hobby astronomers, the second main type of telescope, the reflector, often offers the best value for money. They are known for their high light-gathering power and strong resolution. Instead of lenses, they use mirrors to form an image, which means they avoid chromatic aberration, the color distortion that can affect refractors. A good reflector telescope provides a clear, true-color image, but it tends to offer slightly lower contrast than a lens-based system. The sheer variety of telescopes can be overwhelming for beginners. Finding the right one for your needs takes time, patience, and, most importantly, reliable advice. It all starts with your budget. As a general rule, a solid entry-level telescope will cost between 300 and 500 euros.
So obviously when you buy something, there's never a limit to how much you can pay. You should just think of what it is that you want to do. Do you want to take more photos? Do you want to create images? Or do you have a more visual approach and simply want to enjoy what you see? It might be enough to buy a large reflector telescope, a Dobsonian. This is basically a large mirror with a box around it, and there's also a clear top, just like a Newtonian telescope. And then you move it hands-free to the object you want to observe. You look at it and then move on to the next object.
As a beginner, it's always a good idea to reach out to experienced stargazers. They can introduce you to the world of night sky observation and help you avoid costly mistakes. One point many people overlook is if they have enough space to set up their telescope. And if you want to observe outside a fixed location, your equipment needs to be transportable, along with all the accessories that come with it. Aspiring astronomers should be cautious when it comes to department store or discount bargains. Getting into astronomy doesn't have to cost a fortune, but your first telescope should still meet a minimum standard of quality. Starting out with a poor quality instrument often leads to disappointment, and before long, the dream of exploring the stars is over.
Nichts gegen Discounter.
Well, nothing against discount stores, but it's a bit like using tools from a discount store. It works, but it works very badly. And discount store telescopes, they usually have an absolutely awful mount, so they're going to wobble. Sometimes they're very hard to use at all because they have a strange way of operating. So you should spend a bit more money. But if you want to get started, I'd just recommend going to an observatory. The amateur astronomers you've heard about are actually always very friendly and willing to show you what they have or what the club has. And then you can take your time to decide.
An essential part of any telescope is the mount, the structure that holds the telescope and allows it to track the apparent rotation of the night sky. The mount forms the connection between the tripod and the telescope itself. It needs to support the optics with stability and minimal vibration, which also requires a tripod that's sturdy enough to match. Mounts come in a wide variety of designs, depending on your observing needs and budget. At the high end are computer-controlled systems that use GPS data to determine your exact location and automatically align the telescope with the chosen celestial object.
The sky appears to rotate when viewed from Earth. This is why you have what's known as a mount that rotates along with the telescope. And the larger the telescope, the more stable the mount has to be. If the telescope wobbles, it's no fun. So it's better to invest more money in the mount and less in the telescope.
Refractor or reflector? In the end, it often comes down to a matter of personal preference. Whichever instrument a budding astronomer chooses, it's essential to do the research first. They should also have a clear idea of what they actually want to observe or photograph, and what they want to get out of their observations.
There are two different types of telescopes. Lens telescopes, also known as refractors, and on the other hand, mirror telescopes, so-called reflectors. Now let's take a look at both principles, starting with the lens telescope, which of course consists of a lens, and first of all, a large lens, also referred to as the objective. Its task is to produce the image of the light from a star on a surface. You can see that very nicely here with the lamp. And then I take a magnifying glass to take a very close look at this image. That's the refracting telescope. A reflector works slightly differently. The incident light is reflected by a mirror. But this is a certain kind of mirror, known as a concave mirror. So it's curved, and this is where the incident light is reflected. And I'll use this flashlight for that. The incident light is reflected in the opposite direction and imaged. Here you can see the individual LEDs very clearly, and I can look at them again with a magnifying glass, that is, a lens. So that's the difference. A lens or refractor telescope refracts the light, and a reflector telescope reflects it.
Observing the starry sky has always held a deep fascination, not just for scientists and researchers. In the late 19th and early 20th centuries, societies dedicated to the observation and explanation of the night sky began to emerge. Their goal? To bring the wonders of the universe closer to ordinary citizens. It was during this period that the first public observatories were established.
Well, I think people have always been interested in the stars, but in the 19th century, there was incredible progress in all areas of science, including astronomy. And people have always been interested in the sky, mostly because they were intrigued by the dimensions that exist up there. It's so vast when you look at it from Earth that you can't even imagine it, even if you actually study it.
On July 1st, 1889, the Urania Society opened an observatory in Berlin. Founded just a year earlier, the society was named after the ancient Greek muse of astronomy. The Urania Society was created to make cutting-edge scientific discoveries accessible to the general public. an idea inspired directly by Alexander von Humboldt. The renowned naturalist and world traveler believed in reaching as wide an audience as possible through his public lectures. Berlin is also home to the Archenhold Observatory, which boasts the longest movable telescope in the world. It was established in 1896 as a public observatory for the Great Industrial Exposition of Berlin, thanks to the vision of astronomer Friedrich Simon Archenhold.
If you get to visit an observatory like this, suddenly Jupiter becomes several dots instead of one small dot. You can actually see the moons orbiting around it, or Saturn, my second favorite planet. When you look at it through a telescope like this, you can make out its rings. And it looks just like you would draw it as a child with this perfect ring around it. It's amazing to see that with your own eyes.
Numerous such associations for observing the sky were created at the end of the 19th and beginning of the 20th century. There is also a public observatory in Jena, Germany, where in 1909, employees of the optics company Zeiss formed an astronomical society, also named after the muse of astronomy Urania. The goal here, too, was to expand people's own knowledge through stargazing, bringing the wonders of the night sky closer to the people. With this in mind, the Carl Zeiss Company opened to its employees the use of its own observatory. To this day, observatories like this offer lay people an opportunity to gaze up into the night sky, at the cratered landscapes of the moon, the rings of Saturn, and many other objects in our solar system. But visitors can also see and experience global clusters, strange galaxies, and planetary nebulae with their own eyes, giving them access to the wonders of our cosmos. Observatories offer a very personal view of the night sky, our solar system, and the infinity of the universe.
In my view, public observatories are still a very important instrument for public education, even if that may sound strangely old-fashioned. People can look through the telescopes there and be amazed, because many people have never seen the Moon or Jupiter or Saturn through a telescope and realize that they can actually see them. Apart from that, people who are really interested can go there and make observations, get assistance, and find staff they can join in observing the sky.
Most of these observatories that are open to the general public are still run by knowledgeable amateurs, experienced observers of the night sky and connoisseurs of the visible objects to be found there. Observatories offer telescope observations and guided tours through the evening and night skies, making science tangible. There are also numerous events on special occasions, such as solar or lunar eclipses. They offer lectures and courses on all aspects of what we know about the universe. Major public observatories are true institutions in the dissemination of astronomical knowledge, gateways to the cosmos for everyone.
Anyone who has ever visited one of these observatories will be spellbound by the experience for the rest of their lives. The view through the telescope is like a peephole into the depths of space. Seeing Jupiter as a disk and the moons orbiting around it once in your life is something you won't forget for as long as you live. And it was precisely this image of Jupiter with its moons that revolutionized astronomy and launched the Enlightenment. Why? People understood that the world is not a myth. You can understand it rationally. You just have to look closely enough. But if you want more than that, if you want to understand how planets orbit and the laws behind that, you have to go to a planetarium. That's where you can also see how the universe is structured and how it came into being.
Visitors to the supernova gain a glimpse into the past, but also into the future of our universe. Supernova is what the research organization ESO, the European Southern Observatory, dubbed its planetarium. This educational center with a focus on astronomy is located at Campus Garching in Munich, adjacent to ESO headquarters. The researchers and scientists want to share with the public their fascination for the beauty of our universe and offer insights into their scientific projects and their results. The building was donated by the Klaus Tschira Foundation and is named after the physicist and entrepreneur Klaus Tschira, who died in 2015. It was always important to him to encourage children and young people to develop an interest in astronomy, physics, mathematics, and computer science at the earliest possible age.
You can recreate a virtual space mission, trace the trajectory of the Hubble or James Webb telescope, and visualize what they do and where they are headed in the future. Or you can simply visit a planet. I can fly to Mars, explore its surface. I can fly to Venus. I can look at the entire solar system from the outside. With just a click of the mouse, I decide where to go next. I'd like to go there now, and then you can see it on the screen.
The heart of the ESO supernova is the planetarium. Here, visitors can embark on a journey to the stars, all the way to the edge of the universe. The European Southern Observatory operates its telescopes in the Atacama Desert in Chile. Its observations deliver fundamental results for modern astronomy, and the research facility would like to share these results with the general public in its visitor center.
Most of humanity's astronomical knowledge is stored in the databases of the space agencies. Much of it is available to the general public as well, aside from a few classified topics. Programs like this one draw directly from that data to generate the visual experience projected onto the dome. Does the software calculate the position I want to fly to, or does it generate an image of that location for the audience to see? Right now, I might be in Jupiter's orbit, or wherever, or roaming through space.
Star projectors are used to provide a realistic picture of the visible night sky. They use lenses, mirrors, and precision mechanics to depict stars, planets, and other celestial objects in motion. This gives viewers a perfect illusion of the night sky under the best observation conditions. Unlike purely digital projectors, these miracle machines reproduce the celestial objects with much greater precision, right down to the typical flickering of the stars.
I like to use the term optomechanical projectors, as opposed to digital projectors, because there are a lot of optomechanical elements integrated. Motors and electronics too, of course. But at their core, they're projectors. In the past, stars were projected through pinhole plates, and today through optic fibers, guiding light from a central source all the way up to the dome. This requires powerful optics, along with the electronics and mechanics needed to create dynamic motion.
Every Zeiss star projector is made by hand. The job of the so-called star threader is unique in the world. The individual optic fibers that project the stars are threaded through a plate under a microscope. Each fiber represents a single fixed star, 1 to 400 per plate. The task requires a special talent for absolutely delicate work.
They can, or rather they have to be able to, do something that very few people can. They need to be incredibly skilled with their hands to insert these tiny optical fibers, thinner than a hair, into pre-drilled holes, and then carefully finish them through multiple steps. We really had to search for the right people, because not anyone can do this. I can't do it. My hands are too clumsy for that kind of work. You need a very steady hand and a sharp eye. It's something you either have or you don't. It's not a skill you can pick up.
Depending on the type of projector, there are up to 400 stars on one plate. And depending on the design and size, there are 12 or 32 such plates in a projector sphere. The result is a perfect image of the night sky. The projectors can display a variety of astronomical objects. They also show how our night sky has evolved over the course of time. It can present the view of the stars at the time of Christ's birth, for example. The sheer number of objects they can display make these projectors true technical marvels.
Depending on the class of projector, we have over 7,000 or 9,000 stars per projector. The optical fibers are threaded onto what are known as star fields. We now refer to this process as threading, but in earlier times, the star patterns were engraved. That is, astronomical images were etched into copper plates and then backlit. Today, these plates are fitted with optical fibers. They are joined at the back, and light sources project the light of the stars onto the dome.
The public presentation of the world's first star projector in 1925 left viewers fascinated and amazed. 10 years prior, Oskar von Miller, the founder of the Deutsches Museum in Munich, had come up with the idea of displaying a representation of the firmament inside a dome.
He had a vision, a device that could be used to explain the night sky to the general public. At first, it seemed like a distant dream. But then Walter Bauersfeld came up with a way to make it happen. He was the technical director of Carl Zeiss at the time. And he developed the concept, made the first drawings, and then had it built.
The star projector played a key role in Oskar von Miller's new Museum of Science and Technology. He wanted to show his audience the structure and dynamics of the night sky with the aid of the planetarium.
This is how the miracle of Jena came about. At the time, people couldn't imagine that the starry sky, the entire complexity of the night sky, could be bundled into a machine.
Today's modern planetariums use a computer-based blend of a star projector and several LED projectors. This permits audiences to travel from our solar system to the dawn of our universe and back again. Visiting planetariums to study the starry sky is also a component of basic training for future astronauts.
You learn to navigate by the stars. It's a bit rudimentary, and I quickly realized that it's not that easy, because down here on Earth, we're used to what the starry sky looks like when we look up. You can see the constellations that we're also familiar with here. When you're in the space station and looking out, you're either in the sunlight, in which case it's so glaringly bright that you just can't see any stars at all and the sky is just black. Then on the night side, you have the opposite problem. The sky is so dark and devoid of any atmosphere, so suddenly you see so many stars with such brightness that it's really difficult to identify the constellations because you see too many stars. And I personally had a mission on the space station to find out if you could actually navigate by the stars with a sextant if you were in your spaceship and somehow the systems failed, even though you had a backup system.
Model 1, the world's first star projector, could already display 4,500 stars. Star theaters quickly sprang up around the world, inspired by the Deutsches Museum in Munich. To this day, planetariums across the globe impart knowledge of our solar system and the universe. 100 years after their creation, planetariums have become high-tech astronomical temples where visitors can experience space in remarkable ways. The virtual journeys through space create enthusiasm and curiosity for our world and combine science, art, culture, and education.
Without a doubt, amateur astronomy is a great hobby. And for me, the best part is astrophotography. That's photographing planetary nebulae or galaxies with their beautiful colors. But beware, this is also a challenge. Still, amateur astronomy can also contribute to science. For example, by finding asteroids or comets and determining their orbits, or looking at pulsating stars, because you can deduce their period from fluctuations in brightness. Or you can determine the sunspots on the sun, which are constantly changing, and an indicator of the sun's activity. But you can also contribute to science without a telescope. For example, with Einstein at home. You can share your computing power to help find gravitational waves.
Einstein at home is supported by the private computing power of 500,000 people. This concentrated computing power aims to help detect the signals of gravitational waves. The home computers are networked with the scientists' supercomputers to help evaluate the vast amount of data generated by detectors such as LIGO, the Laser Interferometer Gravitational Wave Observatory. The project is run by the University of Wisconsin at Milwaukee and the Max Planck Institute for Gravitational Physics. Citizen science is the active participation of lay people in a variety of research projects. Another exciting example is the analysis of historical solar observations. The sun's activity fluctuates and has a direct influence on our planet. This was recognized early on. The astronomer Angelo Secchi and his colleagues recorded this solar activity in thousands of drawings between 1853 and 1878. This is probably the most comprehensive data set on sunspot observation in the 19th century. The Max Planck Institute for Solar System Research in Göttingen, Germany, and the Italian National Institute for Astrophysics are now having these drawings analyzed by amateurs. This is how amateur evaluators are helping researchers learn more about our star, the Sun, and places them on the cutting edge of professional science.
So the difference is, as an American once said, an amateur astronomer is an astronomer who's unpaid. That's the definition in scientific circles. Of course, that's the difference, but you can assist professionals in their field. And amateur astronomers simply do their work and are appreciated by professionals because they're free labor, and they even enjoy the work.
The Sun goes through phases of weak and strong activity in roughly 11-year cycles. Periods of stronger activity are characterized by an accumulation of sunspots. These are zones that are cooler than the rest of the surface. The number and development of these spots have been observed and recorded for more than 400 years. This offers a treasure trove of data that is also being unearthed with the aid of amateur astronomers. They are actively involved in the exploration of our near-infinite universe.
Wissenschaftler und Wissenschaftlerinnen sagen, dass es draußen im
Scientists say that there are more stars out there in the universe than there are grains of sand on Earth. You have to think about that for a moment. Next time you're at the beach, just pick up a handful. I think you already have 1 billion grains of sand in your hand, in one hand. And now think how much sand there is on all the beaches in the world, in all the deserts in the world. And there are more stars out there than this number of grains of sand. And we only know of one single grain of sand. That is our solar system, our sun. And yet we venture to predict what may or may not be out there. I think people sense that. I think that's what fascinates us.
Amateurs provide valuable help in other areas of astronomy as well. For example, there is a study that shows that the visibility of stars in the night sky is decreasing faster than expected. The reason for this is the increasing brightening of the night sky due to artificial light. This is also known as light pollution. As a result, the sky over a large part of the land area glows with a kind of artificial twilight long after sunset. The Globe at Night project has been recording the brightness of the sky worldwide since 2006. Of course, the most breathtaking discovery for an amateur astronomer is to locate a previously unknown celestial body. And despite all our modern technology, even today it is the patience of prolonged observation of the night sky that is often rewarded. This is how Joost Jan discovered a previously unknown comet in 2023.
I generally look for small planets, and some small planets actually turn out to be comets. By coincidence, I just happened to discover this one. It was simple. I paused there, wanted to photograph a small planet, and the object was in this field of view and not yet known. It was a little diffuse, but it was very bright. In relation to other newly discovered objects, it was about 10 times brighter, and that made it a little suspicious. And then I asked friends and professional astronomers to confirm that it really was a comet. And that's how I was able to report a comet.
The amateur astronomer used observation time from a telescope that can be controlled remotely via the internet. His discovery was confirmed by the International Astronomical Union, and the comet, which returns every 7.5 years, is now officially named P72023 Jan.
So I'm just happy that as long as humanity exists and astronomers stick to the name, that my name will always be there. That's pretty nice. And the comet is periodic, so it's going to keep coming back.
With his discovery, Joost Jan is now a member of a tiny community. There are only around 600 comets named after their discoverers. And since most discoveries today are made using automatic search programs, there won't likely be many more.
For many people, observing the stars and understanding the universe is a basic need. Once you start, it takes hold of you, and you just can't let it go. Planets come to life. They become tangible. And that's why even the ancient Greeks referred to planets as wandering stars. They have a soul, and the universe is more than just an accumulation of white dots. These dots tell us a story about how the universe came into being and what our role in it is. And most importantly, viewing the sky at night brings you down to earth. It's a hobby that stays with you for a lifetime.
Observing and exploring the starry sky has captivated people for centuries. Not only scientists, but passionate amateurs as well. For the amateur astronomer, it's an exciting and never-ending journey through our solar system and beyond. A journey that reaches deep into the past and into the vastness of the universe. To observe and understand the night sky is to gain both knowledge and orientation, and perhaps even a sense of stability in a world that seems to move faster every day.